How to wire an AC compressor clutch relay. The AC compressor clutch is an electromagnetic device that engages the air conditioning compressor. This unit is composed of three parts: the clutch plate, the hub and the coil. The clutch coil is the one that creates an electromagnetic field around it, which attracts the plate and engages the clutch. The plate is also linked to the drive or serpentine belt and is driven by the crankshaft. The hub and the plate have to be calibrated to a specific gap using a feeler gauge. The purpose of this video is to illustrate how almost all AC compressor clutches are wires. The actual wiring may contain other components, such as transistors and their computer chips, but the control itself is the same. In all cases, these extra components are used to control the relay coil, which in itself controls the AC compressor clutch. This simple circuit can also be used to wire an older vehicle due to lack of parts and high costs. Here is how the circuit works. This circuit has one relay, a refrigerant pressure switch, and a micro switch. The micro switch is a WOT or wide open throttle switch used to disengage the compressor clutch during wide open throttle conditions. This is done to protect the compressor from damage at high engine speeds. Electrical current flows from the 12-volt power feed to the fuse. Then current flows to terminal 30 of the relay. Power is also connected to terminal 85 of the relay coil. Terminal 87 is connected to one of the AC compressor terminals. The other terminal is connected to ground. Oftentimes, the other terminal is tied to the body of the compressor itself, which is grounded. This compressor will be activated by power from the relay. Terminal 86 of the relay is connected to the micro switch, also called the wide open throttle switch. The other side of the micro switch is connected to one side of the refrigerant low pressure switch, also called the cycling switch. This is a normally OFF switch that stays on so long as there's pressure available. In the event that there's no pressure due to a refrigerant leak, then the sensor switch opens, and the compressor is disengaged. Then, from the other side of the low pressure switch we get connected to one side of the high pressure switch. The high pressure switch is normally on, but goes into an open state in the event that the pressure goes too high. As a rule, the sensor switch pressure is calibrated to around 320 psi, which is way too high for R134A or even the old R12. Finally, the high pressure switch is grounded at the chassis. As we can see, this is a series circuit. In other words, all components are connected in series, one after the other. Any disruption in the ground feed provided by each component will disengage the AC compressor. The idea is to protect the compressor from both low refrigerant and high pressure generated by high engine revolutions. This circuit is a straightforward wiring arrangement that'll give you many years of service.